All right, hello once again. This is Jeff Scott of Black Hawk Technical College, and what I'm going to do is something, for me at least, is a little bit different, and that is I've already done a lecture on Chapter 7, but I went back and looked at it, and even though the stuff that's in here is, by and large, is fairly simplistic, I just skipped over a lot of it. I really didn't go over much of it because, as I just said, much of it should seem simplistic to you, but then I thought, if I'm going to be complete, I should be complete. So, I'm taking for granted that you all know this, what the basic assignment operator is. That is the equal sign. Okay, so I'm not gonna I'm not gonna go back and talk about that. Let's take a look at the Swift operators. All right, the basic Swift operators are shown on the top of page 52 in your book. Whoops, and they're also going to be shown here in just a second. Here also. The point is, there's nothing new here. All right, everything that you see on the bottom of your screen should make sense to you. Multiplication, division, addition, subtraction, and remainder or modulo. So in other words, if I do go back and I'm in my playground here, and let's just remove everything that's in here. And I come in here and I import, remember that fairly important to do that in case I need that later, UI kit. But now if I come through here and I say var x equals 10, var y equals 15, var z equals x plus y, well, that should make sense to all of you as far as what's in there, what that's doing, etc. All right, you can see the answers along the side there. I'm creating three variables, and I'm using the type inferencing. Remember, I could have said colon int here and here, and if I wanted to, even here. And if I do that, none of the answers change. Technically, we're making it easier for the compiler to figure out for sure, for certain, that we are creating ints there. However, what's recommended by Swift is that we leave it out because the compiler infers, so it's compiler inference. So again, we get the same exact answer, so I'm going to leave them there that way. So if I come through here and I say var, or try to, var a equals x minus y, well, you should know that. That's 10 minus 15, so it should give me negative 5, which it does. And if I say var b equals x times y, that should give me 150. And again, it does. Finally, if I say var c equals x divided by y, well, what is that? All right. I get 0 because, again, remember, it's division integer by integer. And even though there is a decimal place, I could come in here and force that. And is this how I do it? I don't remember. Double, like that. Still doesn't seem to like that. Let's go back and look in here. I know it's in this chapter someplace. Not where I thought it would be, so let's see. I'll tell you what, we'll come back to it. We will get there. All right? I didn't remember if it was like that. Or if we said double. Like that. Doesn't like that either. Of course, you have to spell double right. And it doesn't like that either. Okay. But it's something like that, all right? Okay. You know as well as I do that if we'd have said var c equals 10.0 divided by 15.0 and hit enter, now we get the right answer. All right, because I'm having a double divided by a double, or a float divided by a float, or whatever we say here. Finally, with a modulo, var d equals, let's do it the other way. Let's do 15 modulo 10, because that should give me 5, because that's the remainder, and there you see it. All right, we see the compound assignment operators on the bottom of page 52 and the top of page 53. So, let's just keep going. How about x, which is 10, plus equals 10? So 10 plus 10, that should come out and say 20. And it does. All right, y minus equal 10, and that should come back and say 5. All right, you can see all these. Z, which is 25, z times equal 5. And since z was 25, 25 times 5 is 125. A divide equals, that was negative 5. Let's say, how about negative 1? Negative 5 divided by negative 1 is positive 5. Okay? And finally, the modulo. So if we say, there's actually a couple more on this also. How about this? Our original x modulo equal y. All right, our original x, which was 10, modulo equal y, gives 0, because we couldn't do the operation to begin with. All right, there's a couple of other ones too. There's a logical AND you can do here, and a logical OR you can do here. All right, doesn't really pay to do them in what I'm showing you right here. All right, now how about this? If x equal y, print they are the same. Let's cut this down because it's pretty big here. Else print, in fact, let's say x and y are different. All right, so here we'll say x and y are the same. X and y. And notice we get x and y are different, and down in our actual console down here we get that saying with the print. Okay? We can do the same thing with greater than. So if x greater than y, so if x is greater than y, we can say x is greater than y, else we can say x is less than or equal to y. And you'll see as soon as we move off, it'll change accordingly. Okay? So we can do all those with equality, inequality, etc. The only reason I'm mentioning this to you is I still get the feeling that at least some of you in here are struggling, going through sometimes what would be probably considered to be the basics. If that's the case, bring up a playground and just start typing in some stuff. All right, anything that you're confused with. All right. Okay, they talk about the ternary operator. Let's get rid of all these except for our first 3 lines that we had in here. So I'm getting rid of all this stuff. All right. And I'm going to say in here var max equals 0. Well, you all know as well as I do that if I say this, if x greater than or equal to y, I don't need the parens, sorry. If x greater than or equal to y, but I do need the curly, print the max is x with a value of, all right, which won't be the case, else print the max is y with a value of, and what we should see in just a second here, there you go. The max is y with a value of 15. But if you noticed, in order to do this, we've got 1, 2, 3, 4, 5, 6, 7 lines of code, which to me seems pretty extraneous. All right, in fact, let's not even do that. Let's not even do a print. Okay? Let's do this. Let's say here, max equals x. Otherwise, max equals y, and then we'll come down here and we'll do a print. Max equals max. And it should still say max equal 15, because that's the biggest number. And there it does. All right, well remember, that's fine as it is, but I can also come through here and I can do this. I can say max equals, and then say x greater than or equal to y, question mark x, colon y. Now I can have the same thing in here, the same print statement. So I can copy that, put it down here, and again, what you see is max equal 15. So in other words, I can take all the code that I had right here in lines 7 through 13 and replace it with a single line. That's the ternary operator. Now, you never have to use that, but sometimes people like to use that because they find that easier to work with. All right? The rest of the stuff that's in here are bitwise operators, and then allows you to compare 2 values, all right, to see whether or not they're equal, but it compares them bit by bit. And you know what? I'll give you a couple of these. And let's look at a bitwise left shift and a bitwise right shift. So I'll leave all this stuff in there. All right, and I'm going to say here var g equals, trying to think of a number I can use here that'll make sense. I don't know if it'll work or not. I'm going to say var g equal 18, and then I'm going to say let's try a left shift on this. In fact, let's use something we're pretty sure will work pretty well here. So let's see. Let's make this 64. All right, and I'm going to say var h equals g caret 3. All right. And it looks like what it did was it left shifted 3 there, and it's giving me a value of 67. So what it does is it moves each thing 3 to the left. So what the heck does that mean? That means the value we had in there was, let's see, 1, 2, 4, 8, 16, 32, 64. 2 times 2 is 4 times 2 is 8 times 2 to the 6th is 2 to the 6th is 64. So 1. So what would be that? That would be 2, 4, 8, 16, 32, 64. So we've got to leave that off. Leave these 2 off. So there's the value 64 right there in binary. Okay? 2, 4, 8, 16, 32, 64. Okay, so now what we're saying is we want to go and we want to move this. We want to shift it 3 to the left. And what I actually did there was not a left shift. I did a bitwise OR, which did move it 3. So in other words, it added 3 to it. So 64 plus 3, 64 plus 3 is 67. So that's why we got that number. But let's try doing it this way. Notice now we get 512. And you might be saying, wait a minute, 64 times 3, 512. I don't get that. All right. Well, first of all, if we took 512 and divided it by 64, we'd get 8. Okay? And if we took 2 and took 2 to the 3rd power, we'd get 2 times 2 is 4 times 2 is 8. So in other words, to take a variable and left shift it 3 is the same thing as multiplying it by 2 to the 3rd or multiplying it by 8. 2 times 2 is 4 times 2 is 8 times 2 is 16. If I change this to 4, this should give me 64 times 16, which is 1,024. So let's see. And you see that it works. Now I could go into a whole big song and dance here about really what I just showed you is how multiplication is actually done inside of the computer. I won't, but I could. Let's go the other way. How about if we say right shift by 3? This should be the same as dividing that by 8. So I should get 8 right there. And I do. If I put another one in there, that's now dividing it by 16. And you see that works. All right. Now, typically, unless you are working on operating systems or the like, you probably would have little to no reason to ever use bit shifting. But it's there in case you need it. All right. When we come back, I'm going to create a flow control. The good thing is Chapter 8 is very small. Chapter 9 is very small. Chapter 10 is sort of where the book changes a little bit. All right, so I want to come back and do chapters 8 and 9 in just a couple minutes.